Hi guys, welcome to Python video tutorial series. In this video, I would like to make a quick revision of Python that we have learned so far. Let's make a quick revision of Python that we have learned so far. So let's get started. We started with how to write and execute Python code in ideally shell. We understood that every Python file extension should be .py. Python file extension should be .py. We use print function to display data in the shell or in the output stream file, right? Next, we understood the print function itself. We understood print function is used to display data in the console. Console is also called shell or other output stream file. Print function is used to display data in the shell or in other output stream file. We know that print function accepts various parameters like value, ... scp, end, file, flush. We understood value ... Value ... indicates you can pass single value or multiple values separated by comma. To the print function, you can pass a single value or multiple values separated by comma. You can see sum of 2 and 2 is a string value, 4 is a number separated by comma. You can see that. So to the print function, we can pass a single value or multiple values separated by comma. Next, we understood scp and end parameters, right? Scp stands for separator. Scp is used to specify the string to be inserted between values. By default, it is set to space. That means if you are printing multiple values using the print function, by default it adds space between the values while printing. If you want to add comma between the values, then you have to override. Here I am saying scp equal to comma. So what happens when it is printing apple, banana, mango? It inserts comma instead of space. Next, we understood end parameter. End is used to specify the string to be printed at the end of the output. By default, it is set to \n. \n indicates new line character. That means if you say print hello world 1, print hello world 2, hello world 1 and hello world 2 are displayed one below another, because after displaying hello world 1, it moves the cursor to the next line. After displaying hello world 2, it moves the cursor to the next line. So hello world 1 and hello world 2 are displayed one below another. If you want to display hello world 1 and hello world 2 one beside another, then you have to override end parameter. Here I am using space. So this print function displays hello world 1 and it displays space. After that, this print function displays hello world 2 on the same line and then moves the cursor to the next line. So that is how the scp and end parameters work, guys. Next, we understood file and flush parameters. File parameter is used to specify where the output should be printed. File parameter is used to specify where the output should be printed. By default, it is set to sys.stdout. stdout means standard output. Standard output indicates the shell, guys. So by default, print function displays the data in the shell. If you want to display in some other output stream file, then you have to override the file parameter with some file reference. Here output-file.txt. Okay, we are taking this file reference, assigning to file. So what print function does? Instead of displaying hello world in the shell, it writes the hello world in the output file.txt, guys. We also understood flush. Flush is used to specify whether to flush the output stream or not. Next, we understood comments in Python. What are comments? Comments are something like notes inside our code, right? Comments are something like notes inside our code. Anything is written after a hash symbol in the line is treated as comment in the Python. We write hash and then we write the comment. What's the use of comments, guys? Comments are used to document the source code, right? Comments are used to document the source code. Here I have written hash author Manjunath. So I am telling author of this program is Manjunath. Date of modification is 0101-0101. Like this, you can document the source code. Comments are used to explain the code logic. Like here I am saying print is a built-in function in Python. Print function is used to display the data in the console. We use comments to explain the code logic so that we can understand the code later or other team members can understand our code easily, guys. Comments are ignored by the Python interpreter, right? Comments have no effect on the execution of the program. If we don't want to execute some parts of our code, we can comment them. Here you can see print hello world 1, print hello world 2 are Python code. I have commented them. So if I run this code, only hello world 3 is displayed because these two lines are comments. So that's about comments. Comments are something like notes inside our code, guys. Next we understood keywords in Python. We understood that keywords are also called reserved words. Their meaning and purpose is already defined within the Python language, right? Keywords are reserved words. They are reserved for specific purpose. Keywords should not be used as identifiers or user-defined names. You should not use keywords for naming variables, lists, functions, objects, etc. Here I have list of keywords in Python. If you want to display list of keywords available in Python, you can import the keyword module and print keyword.kwlist. Keyword list it will display, guys. Next we understood identifiers in Python. Identifiers are user-defined names. Identifiers are names given to the program elements by the programmer. What are the program elements we see in a program, guys? Variable, list, set, tuple, dictionary, function, object, etc. Right? We give name to a variable. We name list, set, tuple, dictionary, function, object. So identifiers are called user-defined names, guys. We name them. Okay. While naming identifiers, we have to follow some rules. While naming variable, list, set, tuple, dictionary, we have to follow some rules, guys. Those are called identifier naming conventions. Identifier naming conventions are the rules for forming identifier names, guys. These are the rules you have to follow. Identifiers should be meaningful. For example, if you are making a game, to keep track of player score, instead of naming the identifier yes, you can name it score, because score is more meaningful than yes, right? In the same way, if you are defining price for a product, name the identifier price instead of P. Price is more meaningful than P, right? So you should name identifiers meaningfully so that anybody can understand what is the purpose of that identifier in the program, guys. Keywords should not be used as identifiers. Continue, break, they are all invalid identifier names, guys. The first character can be alphabet or underscore. First character can be alphabet or underscore. All succeeding characters can be alphabets, digits or underscore. After the first character, you can have alphabet, you can have digit, you can have underscore, guys. No special characters are allowed except underscore. No special characters are allowed except underscore. Like you should not use plus, minus, star in between the identifier names, guys. Okay. Except underscore. Identifiers are case sensitive. You can see here num and num. Both give same meaning. But here this n is in lowercase, this n is in uppercase. So these two identifiers are treated as two different identifiers in Python because Python is a case sensitive language, guys. Okay, so these are the rules you have to follow, guys. What are identifiers? Identifiers are names given to the program elements by the programmer. Identifiers are user defined names, guys. Next we understood variables in Python. What is a variable? Variable is a named memory location whose value can change during the execution of the program. Variable is a named memory location whose value can change during the execution of the program. We understood how to declare and initialize variables. Declaring means creating a variable. Initializing means putting the value in the variable. How do we declare and initialize a variable? We write variable name equal to value. You can see here player score is a variable name, equal to 0 is the value. This is how we declare and initialize variable. If you want, we can change the value inside a variable also, right? Because variable value can be changed. Next we understood constant. We know that Python does not have built-in support for constants, but it's a common convention to use uppercase letters for naming constants. So variable name, in the variable name, if all the characters are written in uppercase, then it is treated as constant, guys. Okay, you should not change the value in a constant at any time. You should only access the value. Don't change. You can get the value, but don't try to set the new value, guys. Next we understood data types in Python. Python provides a rich set of data types to store and manage different types of data values, right? Python provides rich set of data types to store and manage different types of data values. We have bool. Bool indicates conditional result. True and false are considered as boolean values. True and false are considered as boolean values. Int indicates whole numbers, that is numbers without decimal point are called integers, guys. Float data type indicates floating point numbers. Right? Numbers with decimal point are called floating point numbers. Complex indicates complex numbers like 2 plus 3j, where j is an imaginary number. Next we have str. Str means string, right? It indicates textual data. Sequence of characters enclosed in between pair of double quotations or single quotations. It is considered as string in the Python, guys. List indicates mutable ordered collection of items, whereas tuple indicates immutable ordered collection of items. Mutable means you can modify. Immutable means you cannot modify. To create list, we take help of pair of square brackets. To create a tuple, we take help of pair of rounded brackets. You can change the value in a list, but you cannot change the value in a tuple, guys. You lead an error because it is immutable. Range is used to generate immutable sequence of numbers. Like range of 5, it generates number from 0, 1, 2, 3, 4 up to 4. If you say range starting value 1, ending value 5, it generates values 1, 2, 3, 4. You can say range 0, 11, 2. Here 0 is the starting number, 11 is the ending number. You can see 10. It is incremented by 2. So 2, 4, 6, 8, 10. Always it stops at the stopping value minus 1, guys. Next, set and frozen set. Set indicates unordered collection of unique items. So set holds only unique items. You cannot have duplicate values inside it. Okay. Whereas frozen set is a immutable version of the set, guys. It is a immutable version of the set. So if you give set to a frozen set function, it becomes a frozen set. Very simple. Next we have understood dict means a dictionary, guys. Dictionary indicates collection of key value pairs. Collection of key value pairs. Each key is unique, guys. Each key should be unique. To create dictionary, we use pair of lower brackets. It is going to have key value, key value, key value. Where keys should be unique, values can be duplicate. None type indicates absence of value. If you don't know what value to put in a variable, generally you put none, guys. None indicates absence of value. Next, byte array and bytes. Byte array indicates mutable sequence of bytes. Byte array is a mutable sequence of bytes, whereas bytes is a immutable sequence of bytes, guys. So here we have 65, 66, 67, which actually indicates A, B, C, right? 65 is the ASCII value for A, 66 is the ASCII value for B, 67 is the ASCII value for C, whereas 70 is the ASCII value for F, guys. So byte array of 0, we are setting 70. So 65 is replaced by 70. That's the reason it is showing here F, guys. Next we understood type conversion in Python. Data type conversion. Converting value from one data type to another type is called data type conversion. Converting a value from one data type to another type. There are two kinds of conversions, implicit type conversion and explicit type conversion. If required, Python automatically converts a value of one data type to another implicitly, which is called as implicit type conversion or automatic type conversion, guys. You can see var1 is 5, var2 is 3.2. If you say var1 plus var2, what happens here? var1 is implicitly converted to a floating point value 5.0, and then it adds the var1 and var2, gives the result 8.2, guys. So implicitly this value is converted to float. Who is doing that? Python. So it's called implicit type conversion or automatic type conversion. Explicit type conversion. If required, we programmers manually convert a value from one data type to another type, which is actually called as explicit type conversion, guys. Python provides a rich set of conversion functions to convert a value from one data type to another type. Python provides a rich set of conversion functions to convert a value from one data type to another type. Bool function converts given value to bool type. Bool function converts a given value into bool type. Next we have int function. It converts the given value to integer number. Float function converts the given value to floating point number. Complex function converts the given value to complex number. str function converts the given value to its string representation. It converts the given value to string, guys. Next we have list function. It converts any iteratable to a list. It converts a string, tuple, set into a list, guys. Tuple converts any iteratable to a tuple, guys. Set function converts an iteratable to a set. Frozen set converts an iteratable to a immutable set. Iteratable means anything that we can iterate through or loop through, guys. Bytes, byte array. Bytes converts an iteratable to a byte object. Byte array converts an iteratable to a mutable bytes object, guys. So these are the type conversion functions. Next we understood operators in Python. Python provides a rich set of operators to perform various operations like arithmetic operations, comparison operations, bitwise operations, etc. We have arithmetic operators, assignment operators, relational operators, logical operators, bitwise operators, special operators, membership operators, additional operators. We have discussed the arithmetic operators. Plus indicates addition operator, minus indicates subtraction operator, star indicates multiplication operator, star star indicates exponentiation operator, single forward slash indicates division operator, double forward slash or pair of forward slash indicate floor division, percentage indicates modulus operator, guys. Plus gives or addition operator gives sum of two values, subtraction operator gives difference between two values, multiplication operator gives product of two values, exponentiation operator gives x raised to the power of y. So 10 raised to the power of 2 is 100 here. Division operator gives the result in a float value, whereas floor division gives the result as an integer value, guys. Modulus operator gives remainder of the division operation, guys. Next we understood assignment operators. Equal to symbol indicates assignment operator, guys. It is used to assign value to a variable. We have shorthand assignment operators like plus equal to, minus equal to, multiply by equal to. If I say x plus equal to 10, it is same as writing x equal to x plus 10. X plus equal to 10 means x equal to x plus 10. The new value of x should be current value of x plus 10. Here x value is 10, 10 plus 10 is 20, 20 is going to be the new value of x, guys. So instead of writing x equal to x plus 10, you can write x plus equal to 10. Instead of writing x equal to x minus 10, you can simply say x minus equal to 10. Instead of writing x equal to x into 2, you can simply say x into equal to 2, guys. Okay, that's how you can use the shorthand assignment operators. Next we have discussed relational operators. Relational operators are used to compare the relationship between two values. On comparison, they yield the result either true or false. Relational operators are also called comparison operators. We have less than, greater than, less than or equal to, greater than or equal to, not equal to. They are relational operators. 6 relational operators we have. Print 3 less than 4. It displays true. Why? Because 3 is less than 4. 5 greater than 4 is true because 5 is greater than 4. 5 less than or equal to 6. It displays true. Why? There are two conditions are there here. 5 less than 6 and 5 equal to 6. Any one condition is true, result will be true, guys. 5 less than 6 is true, so result will be true. 6 less than or equal to 6. Here 6 less than 6 is false, but 6 equal to 6 is true. One condition is true, so result will be true. 7 less than or equal to 6 is false. Why? Because 7 less than 6 is false. 7 equal to 6 is also false. As both conditions are false, the result will be false. So that's how the relational operators compare the relationship between values and yield the result true or false, guys. Next we understood logical operators. Logical operators are used to evaluate one or more conditions. On evaluation, they yield the result either true or false. Logical operators are also known as Boolean operators. Logical operators are also known as Boolean operators. And or not are Boolean operators or logical operators, guys. And says if both left hand side, right hand side operands are true, then result will be true. In all other cases, the result will be false. The opposite is or. Or says if both left hand side, right hand side operands are false, then result will be false. In all other cases, the result will be true, guys. Not says if the given operand is false, the result will be true. If the given operand is true, the result will be false. Next we understood bitwise operators in Python. Bitwise operators are used to perform operations on bits, that is sequence of zeros and ones. Bitwise operators perform operations on zeros and ones, guys. And how does bitwise operators work? We know that first they convert the given decimal number or numbers to their binary equivalent number, that is zeros and ones. Then they perform operations on bits of the converted binary equivalent numbers and return the result as a decimal number back. To the bitwise operator, we pass decimal numbers. They give the result also in decimal number. But what they do behind the scene? They convert the decimal numbers to binary equivalent numbers. On the binary equivalent numbers, they perform the operation, return the result back in decimal, guys. We have bitwise AND operator, bitwise OR operator, bitwise exclusive OR operator, bitwise complement operator, bitwise left shift operator, bitwise right shift operator. We have discussed all of these operators. We understood special operators. Special operators we have is not, in and not in. Is returns true if two variables refer to same object. Is returns true if two variables refer to same object. For example, here A is equal to 1, 2, 3. A is referring to this list. B equal to A. Now B also refers to the same list. So if I say B is A, it returns true because B and A both are referring to the same list. Whereas instead of saying C equal to A, I am saying C equal to A dot copy. What happens? It makes a copy of this list and assigns to C. So C is referring to another list. So if I say C is A, it gives false because A is referring to this list, whereas C is referring to another copy, a list copy, guys. In the same way, we have in operator. In operator returns true if left hand side operand is a member of the right hand side operand. Like if I say 2 in A, it returns true because 2 is there in this list 1, 2, 3, 4. 5 in A gives false because 5 is not there in the A list here. So that is how the special operators work, guys. Next, we understood Python operator precedence and associativity. Precedence indicates while evaluating a given expression, which operator should be evaluated first before the other is determined by precedence of the operator. That is, which operator needs to be given higher precedence than the other. For example, 2 plus 3 multiplied by 5. Here, if you say 2 plus 3 is 5, 5 into 5 is 25, then it is wrong, guys. 5 into 3 is 15, 15 plus 2 is 17. That is the correct answer, guys. Why? Because if you see the precedence table, multiplication operator should be evaluated first before plus, guys. Multiplication operator should be evaluated before the addition operator, guys. So you should know the operator precedence in Python, guys. So remember, which operator needs to be given higher precedence than the other. That's actually called as precedence. Associativity indicates if same operator appears 2 or more times in the expression, in which direction the specific operator should be evaluated. In which direction a specific operator should be evaluated. That is actually called associativity, guys. If you see here, exponentiation operator, unary operators, not operator, and assignment operators should be evaluated from right to left. Other operators should be evaluated from left to right, guys. So that is about precedence and associativity. Next, we understood control statements in Python. Control statements help us to get the control over flow of execution of code. If you want to get the control over flow of execution of code, you take help of control statements. There are 3 types of control statements we have: conditional or selection statements, looping or iterative statements, jumping or control transfer statements. Conditional statements are also called selection statements. Looping statements are also called iterative statements. Jumping statements are also called control transfer statements. Conditional or selection statements execute a set of statements based on the result of a condition. Conditional or selection statements execute a set of statements based on the result of a condition, guys. If else, else if ladder, match case are considered as conditional statements. Looping statements execute a set of statements repeatedly. If you want to execute set of statements repeatedly, you take help of for loop, while loop. Jumping or control transfer statements directly transfer the control from one place to another place. If you want to transfer a control from one place to another place, you take help of jumping or control transfer statements, guys. They are break, continue, and pass. We understood if and if else statement. You can see here, Python executes the true part if the given conditional expression evaluates to true. Python executes the true part if the given conditional expression evaluates to true, else it executes the false part. So that is if else, guys. Here, if A is equal to 10, it displays A is equal to 10, else it displays A is not equal to 10. So that is if else statement, guys. Next we understood else if ladder. Else if ladder helps us to check multiple conditional expressions. Else if ladder helps us to check multiple conditional expressions. And how it works? Else if ladder executes the statements under the conditional expression that evaluates to true. Else if ladder executes the statements under the conditional expression that evaluates to true. It executes the statements under the else statement if no conditional expression evaluates to true. So that is how the else if ladder works, guys. Next we understood how to find grade of a student in Python using the else if ladder. Next we understood the match case statement. Match case statement checks the given value against the patterns defined in the case block. Match case statement checks the given value against the patterns defined in the case blocks, guys. If match found, the corresponding set of statements executed. If there is a match between the value and the pattern, the corresponding statements are executed, guys. If there is no match, it executes the default case, guys. It executes the default case. Next we understood the for loop. For loop iterates over items of a sequence. For loop is used to loop through the items in a range, list, tuple, string, etc. For example, here for I in range 1 to 6, the range function generates values 1, 2, 3, 4, 5. So for loop takes the values one by one, 1, 2, 3, 4, 5 and displays. Okay, so range function you can see you can use to loop through the list also. So here it gets apple, banana, mango and displays, guys. You can also use to loop through the dictionary, key value pairs. So dict, here we have car dictionary. Car dictionary dot items, it gives us key value pairs. So model is stored in the key, Maruti is stored in the value and displayed, guys. Number is stored in the key, M007 is stored in the value and displayed, guys. So that is the use of for loop, guys. It is used to loop through the items in a sequence. We learned how to display multiplication table in Python. We learned how to display multiplication table in reverse also. Next we understood the while loop. Python repeatedly executes the statements under the while loop as long as the given conditional expression evaluates to true. Right? And how it works? We also Python repeatedly executes the statements under the while loop as long as the given conditional expression evaluates to true. I told you that when you don't know exactly how many times the set of statements to be executed, use while loop. When you don't know exactly how many number of times set of statements to be executed, then you use the while loop, guys. We understood how to find sum of digits in a given number using the while loop. We understood how to display sum of digits in a given number using the while loop. Next we understood the break statement. Break statement is used to terminate the loop. Break statement is used to terminate the loop. If I say for I in range 1 to 6, print I, it displays 1, 2, 3, 4, 5. Here I am saying if I is equal to 3, then break. So when I value becomes 3, it breaks. So it displays only 1 and 2, guys. Okay, you can use break statement in both for and while loops. It's helpful when you want to stop iterating based on a specific condition, guys. We understood linear search algorithm, how to implement linear search algorithm in Python with the help of break, how it optimizes our code, we understood, right? Next we understood the continue statement. Continue statement skips the current iteration, proceeds to the next one. If I say for I in range 1 to 6, it displays 1, 2, 3, 4, 5. If I say if I equal to 3, continue. So when I is equal to 3, it is not going to execute this statement. So 3 is not displayed, guys. 1, 2, 4, 5 are displayed. So that is how the continue statement is going to be used. It is useful when you want to skip specific iterations based on some condition, but still want the loop to keep running, guys. So that is the use of continue. Next we understood the pass statement. Pass statement is a placeholder that does nothing. Pass statement is a placeholder that does nothing. Often it is used to define empty conditions, empty loops, empty functions, empty classes. You can see here if num mod 2 equal to 0, pass. That means if number is a even number, do nothing. If number is an odd number, then display number is odd. So in the same way here, for I in a range 1 to 11, if I mod 2 is equal to 0, pass. That means if I is an even number, don't do anything. Otherwise, just display the odd numbers here. So it displays odd numbers between 1 to 10 here. If you want to define an empty function, just use pass. If you want to define an empty class, just use pass. So that is the use of the pass statement in Python, guys. Next, we understood how to print square and rectangle pattern of stars and numbers using nested loops. We understood how to display triangle and pyramid pattern of stars and numbers using the nested for loop. Next, we understood functions in Python. What is a function? Function is a set of statements meant to perform a specific task. Function is a set of statements meant to perform a specific task. So whenever we want to do a specific task, we create a function for that. For example, if I want to add two numbers, I create an add function. If I have to find area of circle, I create an area of circle function. And I told you, there are different ways of creating functions in Python. One way is using the def keyword. In Python, a function is defined using the def keyword. Functions defined using the def keyword are used to perform simple to complex tasks, guys. Simple to complex tasks. This is the syntax. We write def, we write the function name, in bracket we pass parameters, then we write the statements, and then we write the return statement. While calling the function, we write the function name, in brackets we pass the parameters. I told you that functions in Python are executed only when we call them. And we understood, based on the presence and absence of parameters and return value, functions are categorized into four types. A function without parameters without return value, a function with parameters without return value, a function with parameters with return value, a function without parameters and with return value. And we have seen the different examples for them. Next, we understood how to define a function using lambda keyword. We know that in Python, function is defined using the lambda keyword, where the function is assigned to a variable and the variable name acts as a function name. Functions defined using the lambda keyword are used to perform simple tasks, guys. They are used to perform simple tasks, not for the complex tasks. And we have seen the different examples how to create functions using the lambda keyword. We also understood immediately invocable functions in Python. In Python, immediately invocable functions are defined using the lambda keyword only, where function is called immediately. Instead of assigning a function to a variable, the function is called immediately with the help of pair of parentheses and we pass the parameters there. And we have seen the example. Next, we understood local versus global scope. We know that any variable declared inside a function is considered as it is in the local scope. Any variable declared inside a function is considered as it is in the local scope, whereas any variable declared outside a function is considered as it is in the global scope. So we understood the difference between local scope and global scope and how we can access the global scope variable in the local scope. To access global scope variable in the local scope and modify, we take help of the global keyword. Next, we understood the call stack. We know that call stack is used to manage functions in Python. Call stack is used to manage function calls in Python. Next, we understood nested functions. Nested functions means a function defined inside another function. Of course, in Python, we can define a function inside another function, guys. And remember, a function defined inside a function is accessible only within that function. Next, we understood the recursive functions. Recursive function is a function calling itself. If a function calls itself, it's called as a recursive function. We understood how to find factorial of a number using recursive function, right? We understood how to find factorial of a number using recursive function. And I also told you that if you want to solve a problem using recursive method, you have to identify two things: recursive behavior in the problem and the base condition. Base condition helps us to stop the recursive behavior. Next, we understood required parameters and optional parameters. In Python, a parameter without default value is considered as the required parameter, whereas a parameter with default value is considered as the optional parameter. Next, we understood the positional and named arguments. While calling the function, if you just pass the values, they are called positional arguments. While calling the function, if you just pass values, they are called positional arguments. Whereas while calling the function, if you pass the values along with the parameters, they are called named arguments or keyword arguments. While calling the function, if you pass the values with parameters, they are called named or keyword arguments, guys. Next, we understood variable length arguments. Of course, to the function we can pass variable length of arguments. To pass variable length positional arguments, we take help of star. To pass variable length keyword arguments, we take help of star star, right? So we understood star args is used to pass variable number of positional arguments, whereas star star is used to pass variable number of keyword arguments to a function. We have discussed higher order functions. What is a higher order function? Higher order function is a function that takes another function as the input or returns a function as output. Higher order function is a function that takes another function as the input or returns a function as the output. Next, we understood generator functions in Python. Generator functions return values one by one instead of all at once. Generator functions return values one by one instead of all at once. Here this generator function returns values 1, 2, 3, 4, 5 one by one. Generator functions use the yield keyword instead of return. You can see we are using here yield keyword. So they are great for memory efficient looping, guys. Generator functions are great for memory efficient looping. So that's what we have learned so far in Python, guys. I suggest you people to watch the previous video tutorials. Make the notes, practice all the programs, revise as many times as possible, guys, and become a perfect in Python, guys. In the upcoming video tutorials, we discuss more about Python in depth, step by step with more examples, guys. For this video tutorial, this much is enough, guys. For more benefits and be up to date, do not forget to subscribe to our YouTube channel. Keep learning, keep coding, keep sharing. Thank you, guys. Thank you very much. See you in the next tutorial.